All right, everybody, welcome back to the 2023 FRQ video. So last time we left off in question number 2. So let's see. Okay, picking up right where we left off. So in question number 2, they say, Steven swims back and forth along a straight path in a 50-meter long pool for 90 seconds. Steven's velocity is modeled by V of t, where t is measured in seconds. Let's underline that because that's going to be important. And V of t is measured in meters per second. Find all times t in the interval from 0 to 90 at which Steven changes direction. And then give a reason for your answer. The way you want to tackle this question is by taking your V of t and graphing it with your calculator. Because we are going to look at the function for a total of 90 seconds, make sure that your window goes all the way up to 90. Well, actually, it should go further than 90, right? Maybe go from -10 to +100. When you graph it, the function you get looks something like this. It's just a sketch. What I'm really interested in is the x-intercept, which happens at 56 seconds. Since this is the graph of the velocity, we have to look at the value or the sign of V of t. V of t is positive, V of t is negative. And that means we're moving forward and then we're moving backward, right? So, based on this, Steven is going to change direction. Changes direction at t equals 56 seconds. And we have to make sure to give a reason for our answer, not just the answer. From going forward to backwards, since velocity goes from positive to negative. So I guess a couple of suggestions. If you want to change the window for your calculator, make sure to press window. And for this particular problem, you want your x min to be approximately -10 and your x maximum to be something bigger than 90. Your y min, I'm not sure what my settings were, but it can't be that high, so feel free to mess with that. Maybe start with -5 and your y max as 5, just to get a good graph going. You can always change those as you see fit. And then to find the x-intercept, pues you're gonna have to use second trace 0. Second trace 0. Okay. On to part B. Find Steven's acceleration at time 60 seconds. Show the setup of your calculations and indicate units of measure. Steven speeding up or slowing down at 60 seconds. Give a reason for your answer. Okay. Well, we know we were given velocity. V of t is equal to 2.38 e to the power of -0.02 t times sine of pi over 56, if I'm not mistaken. T. And we want to find Steven's acceleration. So a of t, which is the derivative of velocity, is going to be done through the calculator. So you're going to do a of 60 is equal to -0.036. And for that, you're going to use math 8. The calculator will help you evaluate a derivative. All right, so use it. It's a calculator question. Okay. Now the second part of the question, is Steven speeding up or slowing down? Well, for this, we're going to have to calculate velocity. At 60 seconds, the velocity of Steven is negative 0.16, which can be done by plugging in 60 into your function. Make sure it's in radians. So, since at 60 seconds, Steven's velocity, not just the velocity, and acceleration. Whoa. Where did my work go? And the acceleration are both negative. Steven is speeding up. So, in other words, if acceleration and velocity have the same sign, you're speeding up. Opposite signs means you're slowing down. Okay. Question C. Find the distance between Steven's position at 20 seconds and his position at 80 seconds. Show the setup of your calculations. Okay, so once again, we're going to be finding the distance between his position at 20 seconds and 80 seconds. And to do that, we are basically talking about displacement. We're talking about where was he at 20, where was he at 80. The distance could be greater, it could be smaller because he is going back and forth from a pool. So to do that, we're going to take the integral from a to b of v of t dt. So we have the integral from 20 to 80. And you don't have to necessarily write out the whole function, but you can say v of t dt to set up your work. And this will give me a calculation of 23.384. This is the distance, the meters, that Steven is away from his position at 20 seconds and 80 seconds. Let's take a look at the rubric real quick, see how they phrase it. Question 2C. Here it is. The distance between Steven's position 20 and 80 seconds is 23.384 meters. Okay. I guess I could have phrased it a little bit better, but that's what the rubric is for, so that we can learn. And this takes us to the final part in question 2. Find the total distance Steven swims over the interval from 0 to 90 seconds. Keyword here, total distance. To calculate the total distance that he swims, you're going to take the integral from a to b of the absolute value of v of t dt. So the integral from 0 to 90 of the absolute value of your function. What the absolute value is doing is, let's make a sketch of the graph here. The part of the graph that's negative below the x-axis is basically telling you that Steven is going back, right? What we want to do is make sure that we take the distance and we take it into account as positive distance traveled, right? That's what the absolute value is doing. So plug it into your calculator, and this should give you 62.164 meters. Swam, I guess, right? If that's a word. Let's just write it out mejor. Steven swims 62.164 meters over 90 seconds. Okay. And that finishes part A the calculator portion of the FRQs. Now for the next section, as you can see, we're going to have 1 hour for 4 questions, and we cannot use a calculator. Question number 3. A bottle of milk is taken out of the refrigerator and placed in a pan of hot water to be warmed. You know what? Go ahead and read it, and let me tell you what information is important here. T is minutes. M of T is degrees Celsius. At time T is equal to 0, the temperature of the milk is 5 degrees Celsius. And then, of course, the equation given to us. Part A slope field for the differential equation dm dt is given. Sketch the solution, curve through the point. So again, we're just making a sketch of the solution. In other words, we're making a sketch of the graph of m of t. And as you can see by the given slope field, we are sketching m of t. To do this, start by placing the point given to us. And then follow the lines, because the lines are the slope. So just follow them. Follow, 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 follow. And here the lines get flat, so make sure you don't go past it. It's basically a horizontal asymptote. And then there it is, the solution. Use the line tangent to the graph of m at t is equal to 0 to approximate m of 2. The temperature of the milk at 2 minutes. Okay. So basically, since this is my graph of m, we're going to have a tangent line right here. And we have to be able to write the equation for the tangent line, right? The equation for the tangent line, in simple terms, it's y equals m, x minus x1 plus y1, where m is the slope, aka the derivative. And then we have a point. So we want to make a tangent line at the point when time is equal to 0. So this means that my point is going to be 0, 5, as you can see from the slope field above. Now, the other thing we have to calculate is the slope, the derivative. Fortunately for us, we are given an equation, right? dm dt is equal to 1 over 4 40 minus m, where m is basically your y value. So take your 5 and plug it in. 1/4 40 minus 5 is equal to 1/4 times 35, which is just 35 over 4. That's your slope. So my tangent line is y equals 35 fourths times x minus 0 plus 5. Or in other words, oh, wait. My function here is with respect to t. So t minus 0. This was just the formula that I gave you, right? So this function itself can be simplified to y is equal to 35 over 4t plus 5, my tangent line. Now, we're going to use it to approximate m of 2. The whole idea of the tangent line is that you want to center the line that is going to be really, really close to the curve, which can then approximate values. Watch. M of 2 is approximately here. I'm just estimating, right? The value of M of 2 is really close to the value of the tangent line if you were to plug in 2. And that's what we're going to do. We're going to plug in our 2. to the tangent line, 35 over 4 times 2 plus 5, and we're going to simplify this. 35 over 2 plus 10 over 2, which is 45 over 2. Which, you know, is not that hard to do, so 22.5. So the temperature of the milk at 2 minutes is 22.5 degrees Celsius. Now, of course, this is not exact, ¿verdad? Because this 22.5 is the value of 2 at the tangent line. I said it backwards. The value of the tangent line at 2. But because the tangent line is so close to the function itself, it's a pretty darn good approximation, right? We're off by decimals. Okay, C. Write an expression for the second derivative. Well, let's go ahead and start by writing the derivative. dm dt is 1 over 4, 40 minus m, where m is a differentiable function. So the second derivative is basically 1 over 4 times negative dm dt, or negative m prime, but I'm going to write it as negative dm dt to keep my notation, constant. Why didn't I use product rule? Because there was no need, right? Like, this is basically 10 minus 1/4 m. They're constants. You don't need the product rule. The derivative of 10 is 0, and the derivative of negative 1/4 m is negative 1/4 dm dt. But we need to write our second derivative in terms of m, not dm dt. So then the second derivative becomes negative 1/4, and then this guy is given to us. 1/4 times 40 minus m. So just go ahead and simplify that. Negative 1 over 16 times 40 minus m. This is my second derivative in terms of m. Now we're going to use the second derivative to determine whether the approximation for part B is an underestimate or an overestimate for the actual value of m of 2. Technically, this is a question we can already answer based on the graph that we did, but here, let's go ahead and do it. Okay, so at m equals 2, right? So dm, the second derivative of m is negative 1 over 16 times 40 minus 2, which is negative 1 over 16 times 38, which is negative 19 over 8. But the important thing is that it's negative. Since the second derivative is negative, that means that m is concave down. And because m is also increasing, then the approximation that we did, in part B, it takes me a while to write, is an overestimate. Is an overestimate. And I told you that we can basically answer this question from the sketch that we had done. Check it out. If you look at the graph, the function m is increasing, as you can see in blue, but my tangent line is placed above it. For that simple reason, our approximation is an overestimate. We're finding the value of something higher. So how does this play out with other scenarios? Just on the side, I suppose. If you have a function that is increasing in concave up, then a tangent line approximation would be an underestimate, since our tangent line is below. If our function was decreasing in concave down, the tangent line approximation will be an over approximation. If we have a decreasing function that is concave up, our tangent line would be an under approximation, since it's placed below it. So in other words, basically draw out the function and actually draw the tangent line to see if it's going to be an over or an under approximation. There we go. Okay. Part D. Use separation of variables to find an expression for m of t, the particular solution to the differential equation dm dt, with the initial condition m of 0 equals 5. I love these questions, guys, all right? And if you get one of these in the FRQs in 2024, it's going to be like 3 points, because these are usually worth a lot. Let me take a look at the rubric and tell you what it's worth. This one is worth 4 points, and normally they are worth that much because there's a lot of steps involved. So we start with dm dt is equal to 1 over 4, 40 minus m. Now, as you know, as we talked about in class, the first thing you have to do is separate the variables. So you can go ahead and multiply both sides by dt, and divide both sides by 40 minus m. That gets you 1 point, separating the variables. Your next step is going to be to find the antiderivative. The antiderivative for 1/4 with respect to t is 1/4 t plus c. The antiderivative for 1 over 40 minus m is negative ln of the absolute value of 40 minus m. Just like that. Every time you get a natural log as the antiderivative, you should basically put the absolute value. And for those of you wondering where the negative came in, well, think about it this way. The integral of 1 over u dm, where u is equal to 40 minus m. So that means that du dm is negative 1. When you separate du and dm, you get that du is equal to negative dm, but we only have a positive 1. So then put the negative on the other side. So then this integral becomes 1 over u times negative du. Therefore, the antiderivative is the natural log of u plus c. But we don't have a plus c since we're doing separation of variables. Anyways, this right here is already worth 2 points. Now we have to figure out the value of c by plugging in the initial condition. So negative natural log of 40 minus 5 is equal to 1/4 times 0. So we have negative natural log of 35. That's our c. That's another point. Now, finally, writing the particular solution. You know what? I'm going to have to erase this because I don't need it, but I need the space. Okay. So we have negative natural log of 40 minus m equals 1/4 t minus the natural log of 35 RC. All right, so now solve for m. Start by multiplying by a negative. The natural log of 40 minus m is equal to negative 1/4t plus the natural log of 35. Take e, or use e. 40 minus m is equal to e to the power of negative 1/4 t plus the natural log of 35. Subtract 40. Negative m is equal to e. Okay, and I'm going to do two steps at once. I'm also going to separate this guy using the properties of exponents. So we get negative 1/4 t times e to the power of the natural log of 35 minus 40. Okay, multiply everything by a negative. Negative e to the power of negative 1/4 t times 35 plus 40. M is equal to negative 35e, the power of negative 1/4 t plus 40. And that right there is your final point. Yes, it's a lot of work, but I love these questions because you can get most of your points even if you don't get any of this, right? So keep burning it into your brain cells, separation of variables. Okay, question number 4. A ver, it's 2:15. I have 16 minutes, so yeah, let's go ahead and finish this. So the function f is defined in a closed interval from -2 to 8. It satisfies the condition that f of 2 is equal to 1. We have the graph of f prime. Does f have a relative minimum, a relative maximum, or neither at 6? Give a reason for your answer. Well, neither. Because f prime does not change signs. Right? If you read the graph of the derivative, you know that f is increasing here, then it's decreasing, increasing, it stops, but it continues increasing. So it didn't really have a max or min. Okay. Question B. On what open intervals, if any, is the graph of f concave down? Concavity is talking about the second derivative. If you have the graph of f, you can just look for the shape of concavity, but we don't. We have f prime. So here's a note to you guys. Look at the slope of f prime to determine if f double prime is positive or negative. So basically, again, just looking at the slope. And this is something for you guys to remember, not a part of my answer. If I was taking a test, I just look at the slope. So is f concave down? Okay. Let me erase this. The slope is negative from -2 to 0. And then it's positive from 0 to 4. And then it's negative from 4 to 6. And then it's positive from 6 to 8. So we were trying to see if the graph was concave down. So it is. It's going to be concave down here and here. because the slope of f prime is negative. F is concave down on the interval, or I should say the intervals -2 to 0 and 4 to 6. Since f double prime is negative, or I guess another way you could say it is since the slope of f prime is negative. Simple as that. Find the value of the limit as x approaches 2 or show that it does not exist. Okay, so whenever you start limits, the first thing you want to do is just plug in the limit. The limit as x approaches 2 is 6 of f of 2 minus 6 divided by 4 minus 10 plus 6. But the problem of this is that if you do this, you're going to get a 0 in the denominator. Let me see what f of 2 is. Oh, okay. F of 2 is 1. So then this is basically 6 times 1 minus 6, which is also 0. Okay, don't be fooled by that trap and you go and say, oh, it doesn't exist because it's undefined. No. This is where you use L'Hopital's. Let's see if I spell it correctly. I think you guys and me, we always think of the word hospital because that's how we remember it, right? Even if I misspelled it, L'Hopital's is what you use. Whenever you have a limit where you have 0 over 0 or the limit's undefined, you can make sure that it is that by taking the derivative. So the limit as x approaches 2, and again, take the derivative. 6 f prime of x minus 3 over 2x minus 5. So more specifically, you take the derivative of the top and the bottom separately. And then you can go ahead and plug it in. Let's see if the limit is still undefined. 6 f prime of 2 minus 3 over 4 minus 5. This equals -1. F prime of 2. Since this graph is f prime, it's going to be pretty easy to find f prime of 2. It's is it 0? Hold on, because in my notes I have something else. So let me just make sure. Okay, yeah, it is. So of course, I guess I made a mistake in my notes. 6 times 0 minus 3 equals +3. I made a mistake in my solutions, so careful with that. So there you have it. The value of the limit as x approaches 2 is 3. All right. On to the next part. Find the absolute minimum value of f on the closed interval from -2 to 8. Okay, minimum. From -2 to 8, look, the graph is increasing, then it's decreasing, increasing, and increasing. So if you were to try to sketch a random graph, I would start with a random point, and then I would increase. Like this. Increase. And then, oh, wait, I went too far. You would increase up to here, up to -1. And then you would decrease. I'm just going to do a random sketch. You would decrease decrease, 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 decrease until you get to 2. And right here, you're going to start to increase. So increase, 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 increase until you get to 6. You stop momentarily, but then you continue increasing until you get to 8. So by making this random sketch, I can tell that my minimum is either going to be negative, it's going to be located at -2, or it's going to be located at 2, one or the other. So keep that in mind. The function f of x is defined by the integral from a to x. Let me see, what was it defined as? F prime? F prime. Of f prime of t dt plus f of a. This right here is something that you guys should know. We talked about it during class, right? It's how to write the equation of a function given a derivative without actually necessarily integrating, where this is the initial condition. Initial condition. So then our function of f of x is going to be given by the integral from 2 to x of f prime of t dt plus 1. That was given at the start. Now, to find the absolute minimum, you normally want to check the endpoints and the critical points. This is just your general approach. The endpoints are, of course, -2 and 8. And the critical points are basically your x-intercepts, right? Which, if we look at the graph, is -1, 2, and 6. But let me look at it again. Our critical points would be -1, 2, and 6. But we already identified that -1 and 6 are maximums, or neither. So I'm only really going to check 2, because we want the absolute minimum. So -1, 2, and 6. But we're going to ignore these because this one is actually a relative max, and this one is neither. So we're just going to check -2, 2, and 8. So this is how we do it. Start with -2. F of -2 equals the integral from 2 to -2 of f prime of t dt plus 1. You should change the integral so that it's going from least to greatest and write the whole thing out, right? And now you're going to use areas. So from -2 to 2, we have a triangle. A triangle. Oh, there you go. That's it. 2 triangles. Okay. This equals negative. For the first triangle, it's 1/2 base times height, 1 times 2. And then for the second triangle is 1/2. What was the base? 1, 2, 3. And we're going to say the height is -2. So the base is 3. The base is 3, and the height is -2. That's exactly what we need, because we need negative area. This is 1 minus 3 plus 1, -2, +2, +3. Okay, here's the value for f of -2. Oh man, I think I wrote too big. Okay. If this happens to you in the AP test, make sure that you box out sections, okay? This part I probably shouldn't have written on the actual test myself, just because I'm going over it. So now we're gonna do f of 2. f of 2 is the integral from 2 to 2 of f prime of t dt plus 1. But this one's going to be simple. It's just 1, since the integral itself is just 0. Okay, finally, f of 8. The integral from 2 to 8 of f prime of t dt plus 1. And right here, we're going to use, okay, it's going to get a little tricky. From 2 to 8, we have a triangle. And then we have this half circle. But the way we're going to do this, because it's not the area in the circle that we're looking at, we're looking for this area. So the way you're going to do this is we're going to find the area of this rectangle right here. And then we're going to subtract the area of the half circle. You see that? A rectangle minus the area of half the circle. You gotta get creative like that. Okay, so the first triangle is 1/2 base times height plus, again, the area of the rectangle, which is 8, minus 1/2 pi r squared plus 1. This gives me 2 plus 8 minus 2 pi plus 1, which is 11 minus 2 pi. Now, we don't have a calculator in this section, right? So you have to make sure you understand what this is. Pi is 3.14. So this is basically 11 minus 6.28, which is approximately 4.72. So out of those three values, the absolute minimum is 1. The absolute minimum is 1 at x equals 2. That's your answer. Now, don't get blown away, right? Don't look at the whole problem and be like, damn, I can't get any of that. Like, take it by parts. Because if you look at the rubric, you're going to be given 1 point for considering f prime is equal to 0. And that's what I told you guys about the critical points. You're going to be given 1 point for the answer. Oh, shoot. And 1 point for the justification. The justification can be all the work. Okay. The bell just rang. So I'm going to stop my video right here. And I'll see you guys next time for 5 and 6. Okay. Thank you very much.